Hello, welcome everyone. In this video, I'm going to work out on examples how to take the derivative of natural log functions. So here we have our natural log function y equals ln of y equals ln of 1 minus 5x. So one thing that we have to incorporate when we take the derivative of natural log functions is this, the derivative of e to the x. Okay, so let me just show you how to take the derivative of e to the x. What that equals to is just e to the x times d over dx of this x. So it's e to the x times 1, which is just e to the x. Now what we're going to do, we're going to exponentiate our expression. So it's going to be e to the y equals e to the ln of 1 minus 5x. Okay, so I basically exponentiated the function, or e raised to the y equals e raised to the ln of 1 minus 5x. So here we get e to the y equals just 1 minus 5x. Okay, now we take the derivative of both sides, d over dx of e to the y, and then we take the derivative of 1 minus 5x. Okay, now we have d over dx of e to the y equals d over dx of 1 minus 5x. So when we take the derivative of this, e to the y is just e to the y times dy over dx. Okay, the derivative of y is dy dx. And on this side, we get the derivative of 1 minus 5x. Derivative of 1 is just 0, minus the derivative of 5x is just 5. So we get e to the y times dy over dx equals negative 5. And then we divide both sides by e to the y. So we get dy over dx equals negative 5 over e to the y. Okay, in the next step, I'm going to substitute the value of e to the y into our final answer. So it's negative 5 over, for e to the y, we know that e to the y was equal to 1 minus 5x. 1 minus 5x. Okay, so this is our final answer for this problem. Okay, let's work out another example. Here we have y equals ln of 2x. This is going to be a little bit tricky because first we have to bring this into the numerator. So we're going to get y equals ln of 2x to the negative 1. Okay, so we just use the property of exponents. Now we have like a power rule, and then we have a chain rule, and then we have the derivative of a natural log. So it's going to be a little bit trickier here. So let's work it out. We already know that the derivative d over dx of e to the x is equal to e to the x times d over dx of x, which is e to the x times 1, which is just e to the x. Just remember this part because this is the one that we're going to apply. So now let's apply the power rule here. So dy over dx equals then negative 1 ln of 2x, and then negative 1 minus 1 times d over dx of ln of 2x. Okay, so now we got dy over dx equals negative 1 ln of 2x, and this is negative 1 minus 1 is negative 2 times the derivative of d over derivative of ln of 2x, which is d over dx. That's what derivative is, differentiating this with respect to x, ln of 2x. Now here we have to apply what we learned already, like we know that this thing right here equals, let's say, equals to some y, which is different than this. So y equals ln of 2x, and then we know that e to the y equals e to the ln of 2x. So now we know e to the y equals e to the ln of 2x, and that we know e to the y equals then just 2x, and then derivative d over dx of e to the y equals d over dx of 2x. So this is e to the y times dy over dx. This is the derivative of e to the y equals, the derivative of 2x is just 2, and then we divide both sides by e to the y, so dy over dx equals then just 2 over e to the y, which is equal to 2 over 2x, which is equal to just 1 over x. Okay, so now we can go ahead and substitute here the derivative of ln of 2x, which is just 1 over x. So I'm going to go ahead and write this. So dy over dx equals -1, and then we get ln of 2x to the minus 2 times the derivative that we just got for this portion right here is just 1 over x. 1 over x. Okay, so this is our final answer. Okay, hopefully this helps. The best way to get better at this is just practice. And if you like my video, please subscribe my channel. Thank you.